Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In this video, I will explain about Newton's law. Sir Isaac Newton's have three laws of motion describe the motion of massive bodies and how they interact. In formulating his three laws, Newton simplified his treatment of massive bodies by considering them to be mathematical points with no size or rotation. The three laws cannot be used to describe precisely the behavior of large, rigid, or deformable objects. However, in many cases, they provide suitable accurate approximation. We have Newton's first law. Newton's first law states that a body at rest or uniform motion will continue to be at rest or uniform motion unless a net external force acts on it. The first law of motion implies that things cannot start, stop, or change direction all by themselves. It requires some force from the outside to cause such a change. This property of massive body to resist changes in their states of motion is called inertia. Newton's first law is also known as the law of inertia. Next is Newton's second law. Newton's second law have a formula is F or force equal to m multiplied by a. Newton's second law states that the acceleration in formula is half symbol a of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional of the mass. Mass in the formula is have a symbol m and it's inversely proportional with the acceleration. And the last, we have Newton's third law. It has stated that F action or force action equal to force reaction. When two bodies interact, they apply force on each other that are equal in magnitude and opposite in direction. To understand Newton's third law, with the help of the example, let us consider a book resting on the table. And then the book applies a downward force equal to its weight on the table. According to the third law of motion, the table applies an equal and opposite force on the book. This force occurs because the book slightly deforms the table. As the result, the table pushes back on the book like a coiled spring. Newton's law of motion implies the conservation of momentum. Here, let's say my hands is stable. The book have force downward to the table, and the table have force equal and applies opposite with the book. So there is F action and the table is F reaction. Next, we have Newton's first law example in daily life. Wearing a seat belt in a car while driving is an example of Newton's first law of motion. If an accident occurs or if brakes are applied to the car suddenly, the body will tend to continue its inertia and move forward, probably proving fatal. To prevent such accidents, seat belts are used which stop your body from moving forward in inertia, avoiding danger. Next is example of Newton's second law. It is easier to push an empty shopping cart than a full one because the full shopping cart has more mass than the empty one. This means that more force is required to push the shopping cart. Example of Newton's third law in daily life is a fish use its fin to push water backward, but push underwater will only serve to accelerate the water. Since forces result from mutual interaction, the water must also be pushing the first forward. Properly, the fish through the water, the size of the force on the water equal the size of the force on the fish. The direction of the force on the water is backward. Opposite direction of the force that fish produce is forward. For every action, there is an equal in size. Action-reaction force pairs make it possible for fish to swim. So, the application fish for swim is have force reaction and force action. It's example of Newton's third law in daily life. And we are done. Thank you. I hope you can learn something from this video. Assalamualaikum. Bye bye.